What if I told you that the factory worker of the future won't need a lunch break, won't call in sick, and can learn a new task in just minutes? What if I told you that this worker isn't human at all? Right now, in a factory somewhere, a machine is doing something that should be impossible. It's building a car, not following instructions, not repeating program moves. It's watching, learning, and figuring it out on its own. No human supervision. No code telling it what to do next. Just pure artificial intelligence making decisions in real time. This technology already exists, and it's about to change everything. What makes this robot different? For decades, robots in car factories have been doing the same thing over and over again, welding the same spot, tightening the same bolt. They're fast, they're precise, but they're completely blind to anything outside their programmed routine. If something changes, even slightly, they stop working. They need human engineers to reprogram them, which can take weeks or even months. But this new generation of AI robots is different. They have eyes, they have brains. They can see the parts in front of them, understand what needs to be done, and figure out how to do it. If a part is in the wrong position, they adjust. If a tool isn't working, they find another way. They don't just execute commands, they solve problems. And that's what makes them revolutionary. How it actually works. So how does a robot teach itself to build a car? It starts with observation. Using advanced cameras and sensors, the robot watches human workers perform tasks. It doesn't just record movements. It understands the purpose behind each action. Why is the worker reaching for that tool? What problem are they solving? How do they adapt when something doesn't fit perfectly? The AI processes millions of data points, learning the logic and reasoning behind human decision-making. Then comes the practice phase. The robot attempts the task itself, making mistakes, learning from them, and improving with each attempt. Within hours or days, it can match or even exceed human performance. And here's the most impressive part. Once one robot learns a task, it can instantly share that knowledge with every other robot in the network. The technology behind the intelligence. This breakthrough is powered by three core technologies working together. First, computer vision allows the robot to see and interpret its environment in 3 dimensions, identifying parts, tools, and obstacles with incredible accuracy. Second, machine learning algorithms enable the robot to learn from experience, recognizing patterns and predicting outcomes based on past actions. Third, advanced sensors give the robot a sense of touch and force, allowing it to handle delicate components without damaging them. But the real magic happens when these technologies combine with large language models and generative AI. The robot doesn't just see and touch, it understands context, anticipates problems, and generates solutions on the fly. It's not artificial intelligence mimicking human work. It's artificial intelligence thinking like a human engineer. Real-world applications and testing. Major automotive companies are already testing these AI robots in their facilities. BMW has deployed robots that can assemble complex engine components with minimal human oversight. Tesla is experimenting with AI systems that can adapt to different vehicle models without reprogramming. In China, several manufacturers are using AI robots for quality inspection, spotting defects that human eyes might miss. The results are stunning. Production speeds have increased by up to 30% in some facilities. Error rates have dropped significantly. And perhaps most importantly, these robots can work alongside humans, taking on the dangerous or repetitive tasks while human workers focus on problem solving and oversight. The technology isn't replacing entire factories overnight, but it's proving itself in real manufacturing environments right now. The impact on the automotive industry. The automotive industry is facing massive pressure to innovate faster and reduce costs. Electric vehicles require different assembly processes than traditional cars. Customization is becoming more popular, meaning factories need flexibility. Labor shortages in many countries are making it harder to find skilled workers. AI robots solve all of these problems simultaneously. They can switch between building different car models in minutes instead of weeks. They work around the clock without fatigue. They reduce waste by making fewer mistakes. For car manufacturers, this technology represents a competitive advantage that could determine who survives and who falls behind in the next decade. Companies that adopt AI robotics early will be able to produce vehicles faster, cheaper, and with higher quality than their competitors. The race is already underway. What this means for workers. This is where things get complicated. Millions of people around the world work in automotive manufacturing. What happens to them when robots can do their jobs better and cheaper? The honest answer is that some jobs will disappear. Repetitive assembly line positions are the most vulnerable. But history shows us that technology doesn't just eliminate jobs, it transforms them. The factories of the future will still need humans, but in different roles. Robot supervisors who manage AI systems. Maintenance technicians who keep the machines running. Engineers who design and improve robotic processes. The key is education and training. Workers need opportunities to learn new skills and transition into these emerging roles. Companies and governments must invest in retraining programs, or we risk creating massive unemployment and social disruption. The challenges ahead. Despite the incredible potential, this technology faces serious obstacles. The initial investment is enormous. Small and medium-sized manufacturers might not be able to afford these advanced systems. There are also safety concerns. What happens when an AI robot malfunctions or makes an unpredictable decision? Who is responsible when something goes wrong? Then there's the question of cybersecurity. If robots are connected to networks and learning from shared data, they become potential targets for hackers. A cyber attack on an automotive AI system could shut down entire production lines or even compromise vehicle safety. Regulations are struggling to keep pace with the technology. Governments need to establish standards for AI robotics in manufacturing, balancing innovation with worker protection and public safety. The future of manufacturing. Look beyond cars, and you'll see where this is really heading. AI robots that can learn and adapt will transform every manufacturing industry. Electronics, aerospace, pharmaceuticals, construction, any product that's currently built by human hands could eventually be built by intelligent machines. We're approaching a future where factories are almost entirely autonomous, running 24/7 with minimal human intervention. But this raises profound questions about society and economics. If machines produce everything, what do humans do? How do we distribute wealth in a world where labor is no longer the primary source of income? These aren't just technical challenges, they're philosophical and political ones. The decisions we make in the next few years about AI and robotics will shape human civilization for generations to come. This technology isn't coming, it's already here. The factories of tomorrow are being built today, and the world of work will never be the same. If you found this valuable, smash that like button and subscribe to TechMind for more videos on the technologies reshaping our world. Drop a comment and let us know. Does this excite you or terrify you? Thanks for watching. We'll see you in the next one.